Welcome to Chapter 4, Part 3. In this part, we'll talk about the so-called financial analysis or financial modeling in relation to projects. Financial considerations are often an important consideration in selecting projects. I told you before that senior executives are evaluated based on their ability to create return on shareholders' investments or shareholders' equity. So their performance is, performance of executives is measured in terms of the financial performance of the organization or the organizational unit that they're in charge of. So that's why executives, they always like to think in terms of numbers, most specifically in terms of dollars. So that's why they like to apply financial models of financial evaluation methodology to all kinds of areas, including to projects. Now we're going to discuss three primary methods for determining the projected financial value of a project. Net present value, by far, that's probably the most common method. Then we're going to talk about return on investment. We'll also talk about payback analysis and also internal rate of return. I mean, you will see that all methods are connected. It's just a matter of, I guess, which perspective you are looking at, because at the foundation of all those methods are the so-called interest rate, and also the idea of time value of money. The idea that $1 now has more value than $1 tomorrow. And the reason it has more value because you can take this $1 today and invest it into something. For example, you can simply put it into a savings account or invest it into stock or new business. So tomorrow that $1 will grow to be a bit bigger than that $1. So that's why $1 now is worth more than one money tomorrow. So that's the one of the foundational principles or theories of finance or investments. In order to show you how to calculate net present value, ROI, internal rate of return, and so forth, I created an Excel sheet, and this Excel sheet is pretty much the same. The example that I'm showing you in this Excel sheet is 100% the same as the one in your textbook. So how do you do net present value calculations or modeling? So imagine you have two projects, project 1 and project 2. You have the following estimations of benefits and cost for each of the projects. So in year 1, you're going to end up paying $5,000, so investing $5,000 into this project. So let's say we're talking about developing a website, right? So let's say in the first year you spend $5,000 developing that website. And then at the end of year 1, the website will go live, and then you'll end up spending $1,000 for the next 4 years, maybe for website maintenance. Let's say that includes server upgrades and also a salary of a part-time web administrator. Now the benefits will be, the return, meaning the money that are generated as a result of this investment. So in the first year, when you haven't built your website, the benefit, the return is zero, meaning the website did not earn any money for you. But let's say in year 2, you project that the website will help you increase your revenues by $2,000, and then $3,000 will be generated by the website in year 3, and so forth. Okay, so here your total benefits, and here you have total cost. Okay. Now, what you need to do, you need to calculate the net benefit, or the so-called cash flow. So you have money coming in, which are your benefits, and money coming out, which are your costs. So what is the net flow? Meaning, what do you have on your hands as a result of that? So in the first year, you have negative outflow of $5,000. That's why it's in parentheses. In accounting, negative amounts are often depicted in parentheses. Then here, the cash flow is $1,000, meaning minus $1,000, which is your outflow cost, plus 2,000 equals 1,000. So here it's 2,000 because minus 1,000 plus 3,000, or simply subtracting 1,000 for 3,000 gets you 2,000. So those are your cash flows. Okay. And the same thing for project 2. So here the cost structure is a bit different. You spend only 2,000 in year 1, then you spend a little bit another 2,000 in year 2, and the benefits materialize in year 1, and then you have the following amounts in subsequent years. So you calculate the same kind of net cash flow for project 2 as well. Now, there is one interesting observation. If you look at cash flows, net benefits, they're the total, right? They're the same, right? They're the same for project 1 and project 2, $5,000. So that's your positive return. The question becomes, are those two projects equivalent or not? Well, as it turns out, no, because here we have, if we apply this principle of time value of money, you'll see that for this project, we invest a lot of money up front. So in other words, we pay $5,000 now, right? And here we only pay 2,000 now, and then the remaining 2,000, the next 2,000 in year 2, and then 2,000 in year 3, right? So here we pay more money up front, here we pay money a bit later, right? So because of that, if you apply the principle of time value of money, this project 2 looks a bit more attractive. And how do we know? Well, by using the net present value formula, okay? Now let me show you how net present value formula works before I give you some computational details. So what you need to do, you need to come up with those net benefits or cash flows, and then as a first parameter for the NPV formula in Excel, you specify the ongoing interest rate. So it kind of means that you can invest your right now the ongoing interest rate is 10%. So you can easily, as a company, instead of putting your money in any of those projects, you can invest it and you can get 10% return, right? So giving that the ongoing rate of return, what is the present value of all those cash flows? So that's what NPV formula helps you calculate. And then, so the first parameter is the interest rate, which is B1, and then the second parameter is the range of cash flow. So it's B1 through B7, right? So giving this interest rate and giving those cash flows, you'll see, the formula calculates that the net present value is 2,316, and here it's 3,201. Of course, if you change interest rate, if the interest rate is higher, then the net present value will become lower. So for example, let's say right now the ongoing interest rate is 30%. Let's say the economy is booming, there are so many opportunities to invest. So you see, in that case, those projects provide you negative return. It means that it doesn't make any sense to invest into those projects, right? I'm sorry, I put a lot of that. So it's in percent, so let me put 30%. Yeah. So you see it becomes negative. Here it's like very low, okay? But let's go back to 10%. Now, how those NPV values are calculated? Well, what happens is that you're bringing everything, like all those future cash flows, meaning cash flows in year 1, at the end of year 1, 2, and 3, to the present moment. And you use the so-called discounting formula. So what you need to do, every cash flow is discounted using the following formula. You divide each cash flow by 1 plus R, which is your interest rate, which is this. So it's 1 plus 0.1, which is 10%, raised to the power of n. Now n means the number of periods from the present moment. Now if it's year 1, then n is 1, because here again we are talking about present moment, and year 1 means at the end of year 1. That's the assumption in this table, okay? So it's 1, okay? Sorry, I didn't put equal sign. All right, so that's your deflator. And by the way, you need to basically divide this amount, so basically the flow, the cash flow, by 1 plus interest rate raised to the power of n. So it's 1, okay? And what I will do, I'll just copy this formula for all cells, but here I'll just correct. Instead of 1, I'll put 2. Here instead of 1, I'll put 3 because it's 3 years from now. Here instead of 1, I'll put 4. And here instead of 1, I'll put 5 because it's raised to the power of n. N is 5 years from now. So here you have those discounted cash flows. If you add them all up using the sum function, like this, you'll see that this amount is exactly, after rounding, right, it can be rounded to $2,316.35. It's exactly as this amount, right? So that's how net present value formula works. You don't have to do all this manual discounting. Just plug in the interest rate, the cash flows, and it will do, the formula will do all those calculations for you. Now, just keep in mind there are like some nuances when it comes to applying those formula. It also depends like when those cash flows are materializing at the beginning of the year, end of the year. I told you that the typical assumption that when you have something like that, a column for year 1, it means at the end of the year. By the end of the year, you'll spend $5,000, right? Because if it's like you spend half of it in the beginning of the year, the other half at the end, then the calculations become different, because what you spend now, it's not subjected to discounting, it's money now. What you spend at the end of the year is 1 year from now, so you divide it by 1 plus R raised to the power of n, okay? So this is how this discounting works. Next, we're going to talk about ROI, or return on investment, another popular financial model for calculating financial return for projects or any kind of other investment. So how does return on investment work? Well, the first thing you need to do, you need to discount, just like we did last time, you need to discount your cost, and you also need to discount your benefits. In other words, you bring all those money outflow costs or money inflows to the present moment, okay? And you're using the same formula I showed you before. It's the amount divided by 1 plus R, interest rate, which is this one, raised to the power of B4. Now, B4 is periods from now, so it's N basically, right? So I'm just using a more general formula here. So you're calculating all those discounted costs, discounted benefits. Here you have totals. So ROI is calculated as follows. Total discounted benefits, which is this value, minus total discounted cost, which is this value, 7,000, divided by G10, which is total discounted cost. And the return is 31.19%. So it basically means after adjusting for this principle of time value of money with the ongoing interest, it looks like the project provides you a return of 31% over and above what you would get if you put it like into a savings account, right? So basically, if you invest, for this particular project, if you invest $1 million, you'll get $310,000 return of profit after 5 years, right? Then the question becomes: is it an attractive rate of return or not? Well, it seems to be above 10%, so probably attractive. Okay, so that's another way to model financial return. Or you have internal rate of return. So basically, it's a formula that you use, IRR for the following cash flows. So what IRR tells you is this: what kind of discount rate you need to apply to those cash flows, right, to bring the present value of all those net benefits to zero, right? So if it's 38, it means, well, the ongoing internal rate of return is around 38%, meaning it's highly profitable compared to the prevailing discount rate of 10%, right? So in other words, it kind of tells you that this project is more profitable than what you expect, because you expect to get 10% return, but you get 38. But this project gives you all 100% return. So of course you will select this project giving the internal rate of return. There's another financial model, it's called payback analysis. So what you do, you calculate cumulative costs and also cumulative benefits, right? And again, to make those calculations possible, you discount everything. You bring everything to the present moment, right? All the costs and all the benefits. And then you calculate cumulative cost by summing discounted costs for this period plus all costs from prior periods. For example, for this period, it's this plus this amount, meaning the cost for this period plus all previous costs. So it basically means like how much money you spend in total. Okay, so you bring everything to this common present value denominator. And you're doing the same thing with benefits. And then you plot those two lines. So this orange line shows cumulative benefits, and this blue line shows cumulative costs. So this is the overlap. So what this graph tells you, as you can probably guess, is that here at around year 4, you have the so-called break-even point where cumulative benefits start to outgrow or surpass cumulative cost. So basically it tells you that you will break even in 4 years. Again, if your organization likes a low-hanging fruit, something that will give return within 1 or 2 years, then maybe given this payback analysis, you will not go for this project. However, if you have long-term horizons, then maybe you can say, well, it seems to be an attractive project. After 4 years, we'll break even, and then we'll start making money as a result of investing in those projects. So these are financial models that are often used in evaluating investments in projects. We're going to talk about some other approaches, and those approaches, they're hybrid approaches. They combine both quantitative and qualitative considerations. One of those approaches is the so-called weighted scoring model, and then you also have a balanced scorecard approach, and we're going to talk about those two in a second. So what is simple weighted model? It works something like this. You come up with qualitative factors, meaning the factors that you're going to use for evaluating your projects against. For example, does this project support key business objectives? So it's more like qualitative factor, right? It's not like a financial factor. Does your project has a strong internal sponsor? Does your project has a strong customer support? And then you find a way to assign a score based on those 8 dimensions to each of the projects. It could be like a Likert scale. For example, you can have a statement: this project supports key business objectives, and then you need to select strongly disagree, which gives you a point of 1, or strongly agree, 0.5. It gives you 5 points, right? So you rank it from 1 to 5. Here it's like a 100 scale. So each project gets a score for each of those factors on a scale from 0 to 100, right? And then each of those factors has a weight. 25% means it's an important factor, 15% means it's a bit less important. And then what you do, you adjust those scores by weight. So to calculate a final weighted score, you multiply 0.25 by 90 plus 0.15 times 70. So all those things combined, when you multiply each score by its weight, and by the way, all weights sum up to 100% naturally, you get 56. So that's your weighted score. So based on this weighted score model, you see that project 2 is the most promising one. So this approach combines both quantitative and qualitative considerations. Now, one popular approach that is based on a similar model, like weighted scoring model, is the so-called balanced scorecard approach developed by two professors, Norton and Kaplan. And there is a website, because those two guys, they started their whole consulting practice that that helps organizations implement balanced scorecard approach, for evaluating executives or evaluating organizational performance. To be honest, it's a vast subject. They wrote at least 2 books that I'm aware of on this subject. They established their own consulting firm that helps companies implement balanced scorecards. I know some business schools, they teach courses, like there is an entire course devoted to balanced scorecards. So I'm not going to go through all those details because there are a lot of things to discuss. But the bottom line here is that what they're telling you if you are evaluating performance of your company, you should not look only on financial indicators, right? That will be quite misleading. You also need to look at the customer perspective. For example, if you're evaluating a project, not only you look at the financial return by doing net present value analysis or ROI analysis, you also ask yourself the following question: will this project benefit customers? Will it increase their satisfaction or loyalty? You also need to make sure that this project contributes to internal processes. Does this project seem to improve internal quality or the speed of internal processes or the efficiency of internal processes? And also, your project needs to invest, it needs to help the company in terms of innovation and learning and growth. Because if you don't invest into your own growth, learning as an organization, then you're not going to grow, you're not going to be successful. So basically, it's like this holistic approach to evaluating something. So that's what balanced scorecard is all about. Okay, so this completes part 3 of chapter 4. Thank you for watching.